Hey, it's John here, and we are going to continue looking into Datomic, how it works, and working with it. This video we want to just create an instance of Datomic in memory, something that'll just be used by our closure process and nothing else, and will disappear once we're done with it instead of being written to disk. Then next we'll look at the building blocks of a Datomic database, the Datoms, and then finally we're just going to look at some example Datoms from an empty database, just what comes out of the box to sort of bootstrap the Datomic system. So let's go ahead and get started. The first thing we need to do is to use the API. So obviously you need to reference it in your project. So we can say Datomic API. We'll call it D. Run that. We will okay, so we have our D. The next thing we want to do is define a URI for our database. So that's a string that always starts with Datomic, and then we'll choose which type of transactor it's going to be in memory, and then we just need to give the database itself a name, and then call it intro. Then we want to connect to the transactor. We're going to define our connection and run d connect to the URI. I made a mistake. Before we can connect to database, we need to create it. So we can do d create database URI. So we create the database, then we can connect to the transactor. I'm being a little bit careful here to say connect to the transactor because you really need to think about databases as values separately from the system that manages these values. So the transactor is what writes to the database and handles some basic things, and then the peers will be the things that let you read and work with the data in the database. So here we're connecting to the transactor, and with this connection we'll be able to get database values or write to the database. Okay, so now a little bit about how Datomic stores things. It stores things in a tuple called a datum, where you have an entity, an attribute, a value, a transaction, and whether it's asserting or deserting. So really, this is some number that's unique in the database for an entity. This is another number, which is a specially defined entity that's an attribute. So this could be, say, 2. The value here can be some kind of object, or it could be a date or a string or a floating point number, something along those lines. A transaction is just going to be a point in time when this datum was asserted or deserted. So it's going to be another number. And then asserting is going to be true or false. So when facts or datums are added to the database, when we say this is valid, then that will be true, and if it's not, then this will be false. So then Datomic is just a huge list of these things, and then databases will give you what these values are as of a given time. And then you can also query the history, so not being limited to a certain time based on transactions, but how things looked throughout history. As long as you kind of keep in mind that that is all there is to Datomic, then it'll sort of help you think about how things work in Datomic. So there is a way to just grab all the stuff out of the database, and let's make a little quick function here to get the database. So we're going to call it getDB, and all it's going to do is do DB on our connection. So basically, go to the connection, go to the transactor, and say, hey, give me the current database. And so when we do that, we're going to get back this this value. Run db, get db. Now we have this datomic.db db, and that's an immutable value. Okay, so once we have this value, and let's just go ahead and say, let's just make db database. Okay, we're just gonna have database now there to always just go grab. And so we can run a function Datoms on our database, and then we have to tell it which index we want from our database. So the standard one is EAVT, so it just says there's an index in the database for looking at the datums as EAVT. There's also one for AEVT, attribute entity value time. This one is entity attribute value time, so everything's going to be sorted in that order. And so if we run this, then now we have I believe it's a lazy list of every entity in the database. So what we could do is we could do into vector, and that will give us everything in the database as a vector. Alright, so now we have, as of this point in time, everything in the database inside of this vector. And here you can see this datum data structure. The entity here is 0, the attribute is 10, the value is this keyword, the transaction time is this big long number, and then true means it was added. So since this is basically the database bootstrapping, then everything's just added. So what is this 0 entity? You can run the dEntity function on the database and give it that value, and it's going to give you this thing. The enclosure, it looks like it came back as a map. It's not exactly what it is. It's an entity map, and you can do cool stuff with that, like if you merge an entity map with a regular, scroll up, I don't know why that's being goofy. Okay, if you start this thing over here real quick, acting crazy. if you merge an entity map with a regular closure hash map, then it's going to give you all the defined attributes for that entity. So just run everything again. Okay, so now we're back to where we're. Okay, so now if I say merge with an empty map, that entity map, then I'm going to get all of its attributes. So this attribute is the ident, and the ident turns out to be db.part, which stands for partition, and then db. So this thing is really, it's just a keyword with namespaces, and then a bunch of things. It's kind of confusing because it's all sort of circularly referential at this point. Like if we say, give me number 10. Oops. Oh, I need to get in this namespace here. Okay, if we say give me number 10, and an alternate way to grab everything is to say d-touch on an entity, and it will also give you everything. So here's where it looks confusing, right? When we say what's the db ident of this entity, it's a db ident, so it's sort of describing itself. So it just shows you how, you know, the database is essentially described in terms of itself, and everything really just boils down to an entity, which is some number, an attribute, which is another number that points to another entity, and then some value of varying type. And this is, as far as I know, the only place where data types really come into play. You know, an entity, if you make an entity, it's just some number, you know. It doesn't have any type. You can't say anything about an entity except what kind of attributes have been asserted about it. All the attributes that have been made, they have a type. So you know what type attributes have, and then the final piece is that makes it powerful is everything is recorded as a transaction of being asserted or not, so that you can go back through time and see how things used to look or when they changed, and all the kind of stuff that you would have with version control that you really wished you had in a database. So having this database that never forgets anything is really powerful. Another way to think about the schema for me that makes sense is what types of schema would you add that would make the database perform faster but not limit you in any way. So if you have some notion of types and how to, you know, convert bytes into something usable, that can help speed up performance. But if you limit what things can be, what attributes they can have, and things like that, then that only burdens the programmer with following some rules of the database. So if you think, you know, what kind of schema rules are there, just think, what kind of schema rule could I make that would make this system run faster? And that seems to be the logic behind it. So I think that's enough for this video, so thank you for watching.